So today I'm gonna image the Messier 8, like a wide field image with the evoguide. It's gonna be fun. I'm gonna image it in narrowband. I have imaged, as you can see, is the evoguide here and 405cc. I have imaged these targets, the M8 trifid nebula and the Chinese dragon nebula. I have imaged them singles before, like by their own, but now we are gonna image them all of them at once. We are gonna see what the evoguide is gonna do on all of them. So as you can see, this is stellarium. I'm gonna show you the field of view we're gonna get. This is the field of view. It's awesome. We can fit all these nebulas inside of the frame with the big 405cc sensor, and the trifid nebula, the lagoon nebula, and the Chinese dragon nebula. And I'm also planning to image the lots of parts of the Sagittarius arm of the galaxy, where there is the Milky Way. As you notice, this is the Milky Way. It goes up from the south side, and as you can see, it's not very high. Here in Malta, these targets remain a bit low. So if you are in the southern hemisphere, these targets will be way up here. Not like we see them from here, but still in narrowband they're very manageable. Make sure to hit that thumbs up, subscribe, and share my content, please. So that will help me a lot, because I need more reach to keep this channel successful. It's pretty exciting for me to start using it again. And I bought this mainly for nebula imaging, which is great at what it does. It's a wide field telescope. It's probably normally a guide scope, not a telescope, but as I mentioned before, it takes really good images. And it's balanced, I believe, at the moment. Let me check. Tighten this clutch. Yes. Okay. And balanced here as well. This is a good weight I bought. This is from AliExpress. It's about 15 euros, something like that. And it came really, or 20 euros, something like that. It came really helpful, because normally my Adventure HDI came with only a 2.2 kilos weight, and that is too much weight for the evoguide. So you need to find something else to counterweight the weight of the evoguide, because the evoguide is a very light telescope, so it doesn't need much weight here. And this works pretty well, as you can see. It's pretty balanced. Awesome. Power adapter, the cap, a white cloth, so we can do flats later, and lots of cables, lots of adapters, lots of button off mask, as you can see. I'm gonna put the dew heater on as well. And so, as you know, in the summer the nights are particularly short, and I'm not gonna put out the whole setup for just one hour of imaging. So what I'm gonna do is I'm gonna leave it overnight, sleep, and hope everything runs well. I don't really like doing that, but you know, I don't really have a choice in this case. So I'm not gonna do all that work for just 1 hour of imaging. At least I need to do 4 hours of imaging for this to be worth it. So everything is set up. As you can see, I have a mess of cables here. 12 volts for the dew heater. I actually put the dew heater on, as you can see. I put this to protect from the sun at the moment, because it's a bit hot still. Cooler for the camera, for the laptop, to charge the powered USB hub. I highly recommend getting one of those to keep your things running smoothly. A button of mask, it's seen better days, but it works. And that's it. Now we wait for the night. Okay, so I'm gonna start the polar alignment on Sharpcap. I will increase the exposure a bit, because since I'm using a narrowband, It's not showing much stars at all. Okay, this should be decent, I guess. I'm gonna increase the black level a bit as well. So let's go to tools, color line, and as I've shown in previous videos, first thing you have to do is loosen the array clutch and turn the mount to 90 degrees and tighten it there. Then press next. Will plate solve the area. Okay, press next again. Sorry for I'm using a phone. Loosen the clutch, turn it to 90 degrees the other side. Okay, I can leave it. Actually, it's better if I tighten the clutch, because if it moves slightly, it will not be accurate. Now, it's solved. Okay, press next, and now this is the error we have. 2 degrees error. So now we have to leave the scope as it is, and now have to turn the mount has adjusting nuts. It has this one and this one control side to side movement. This one controls up and down, so you have to turn those until this number reads 0 or very close to it. The closer you bring it to 0, the better the tracking will be. So I'm gonna adjust now, and it's showing you right and up where to move. As you can see, it's decreased quite considerably. I think there are not enough stars to plate solve. I'm gonna do 3 seconds exposure, because the sky is not very dark yet, so it's not plate solving good. As you can see, I'm very close now, so I'm gonna do very small adjustments. As you can see, I went too far there. Really small adjustments. You preferably wanna get it till it says excellent. Okay, just a little bit more, reduce the down. That's it. Excellent. Polar alignment is done. Took about 2 minutes of fiddling around, and it will take less if you use normal, because without a narrowband filter. Narrowband filter makes polar alignment difficult, because it makes everything dark. So I'm gonna connect my mount. As usual, first COM port, connect. As far as stars, I'm gonna use Vega and Antares. Those are good candidates. Oh, I cannot choose Antares. I have to choose another one. Let me check what's available. I cannot choose Antares, I'm gonna choose Isar instead. Sometimes this happens, depends on the time that you are checking what's available. And I'm gonna change the Sharpcap settings, plate solving, to 242, since this is the focal length I'm using today. Don't forget to do this, but actually I can see Vega here. Most probably it is, at least. I will double check, of course, because if you are off, yes, it's Vega, that one. Because if you are off, it will throw your whole alignment. As I've done that before. I've done that. I don't need to play it solve, and then it is the wrong star actually, and it messed up my whole aligning. Let me double check. Yes, okay. Just center it a bit more. And I didn't do the flats yet because I need to adjust my field of view first. And actually I'm gonna focus as well. I think I'm pretty close to focus, but oops, button of muscle. Okay, I think should be perfect focus, I think. Yeah, it's perfect focus. And I focused that by eye. Sorry. I didn't use any button of mask, which shows how accurate you can get by eyes. So it's not the end of the world if you don't have a button of mask to use. But obviously button of mask is much more accurate, so I would highly recommend getting one. Because when you are a beginner, you won't get that close. I'm experienced a bit, so it's easier for me. Easier. I think it's this one. Yeah, okay, it's this one. Is this we are seeing in the center? Center a bit. Alright, alignment done. Now go to Messier 8, and I'm gonna as you can see, it's the evoguide is turning, and I'm gonna check the field of view so I can do the flats. I'm gonna increase the contrast a bit because I had to decrease it. Turn on the cooling so the camera will cool. When it's the summer, a pro tip I can give you is don't crank the camera down to 0 degrees or more, because you'll get frost on the sensor. First I will do it like 15 degrees, then we'll decrease it later. I can do it like 13. Because if you cool it down instantly, you will get frost on the sensor very quickly. I will take a test shot so I will know where I am. And actually I screenshotted the field of view of the stellarium so I can know where I have to point. I think I'm upside down actually, because if I remember well, I get my other phone. Don't worry that the stars are trailing, because I haven't given the mount time to stabilize. I will check the field of view. This is the field of view I want. If it will focus. This is the field of view I want. The lagoon here and the trifid here. As you can see, the lagoon is here. The lagoon is here and the trifid is here, so we have to turn the camera around so the trifid is here. I'm gonna do that now. Okay, I've managed to turn it around, and this is the way I want it to be. Now I'm gonna adjust the mount so it's more upwards, so we can get the Chinese dragon nebula as well. Let's just bump it up a bit. Alright, I think this will work out good, because down here there's the Chinese Dragon Nebula somewhere around there, but obviously it's not visible because we are massively gained up, so it's very noisy, the image. Okay, the frames are finished and I'm gonna hope that they work, because if you haven't ever used the 294 camera, the 294 camera is a real pain to do the flats on, because most of the time they don't work. It's all over the internet, this problem is not just me. I will hope that they work. So I am 25 minutes in, and as you can see, there's the Chinese Dragon Nebula here starting to show up, lagoon and trifid. And I will try to take at least 3 hours exposure. We'll see how the night goes on. I had to do dithering every 90 seconds because I was getting a ton of walking noise. I'm still getting slightly, but not bad as before. Walking noise is a sign that your tracking is very good. If you're getting a lot of walking noise, it means your polar alignment is spot on. Because what walking noise is basically is like pattern noise. It stays in the same place, and if it keeps stacking and stacking at the same place, it will start to get walking noise. I have the filter on to reject star trails. It's rejected 2 so far. Stars are pretty good. And the camera is getting cooled. Actually, I'm gonna cool it a bit more. I'm gonna put it down to 8 degrees. So I'm this particular stack is I'm 1 hour in, but I have another hour as well, because I had to stop it because it was getting a bit of walking noise. And with all equatorial mounts you reach a point where you have to do a meridian flip, because it passes the half point in the sky, so I have to do it now. As you can see, it's pointing there, and I have to do a meridian flip. So what I do with the GTI particularly, so I'm gonna expose the stack. I'm gonna do a live view and go to. And what it's doing now, it's gonna basically go around, point at the same object in the sky, but it's gonna go around and do a 180 degrees. And now we have a problem, because the image will be flipped upside down. So what we are gonna do, you can flip the telescope or the camera 180 degrees, or in Sharpcap you can basically align the images. You can align the images to how they were basically, and Sharpcap will recognize that you did a flip and will continue stacking to where you were. Okay, so now it's continuous sticking, and as you can see, I didn't touch the camera or anything. The image at the moment I aligned it, but it's flipped in the live view, not like this. And Sharpcap has recognized that I did a meridian flip, and it continues stacking. It's really great, so we don't have to mess around with flipping the image, flipping the telescope, because then you have to, for example, if you took flats, you have to retake the flats and lots of messing around. It's better if you don't if you don't flip in the first place. I don't know if it's the case with normal stacking. I think with normal stacking the software will recognize as well that you are the meridian flip and will continue stacking anyway, but I'm not really sure. But in this case it works out. And so far I have about 3 hours of data, almost. So we'll see. Dawn is about, as you can see, it's 01:25 here in the morning, and dawn here is about 4 o'clock, 4:30 dawn. So we will take as much data as possible, and we'll see the result later.